Okay, in this video we're going to do some basic probability examples. So the first one will be dealing with this chart of data. So let's look through the chart. So it gives exam grades on the top and a year in school on the left-hand side. So this is like a first year, a second year, a third year, and a fourth year. And how you want to read this is that of everyone in the class, 2 people were first years that earned an A, 4 people were first years that earned a B, and so on and so forth. So maybe 3 people are third years that earned a C. Okay, great. So now let's go ahead and fill in the rest of the chart. What I mean by this especially is these total columns. So notice the total number of first years in the class is 2 plus 4 plus 1, so that's 7. The total second years is 3 plus 5 plus 2, so that's 10. The total third years are 8, and the total fourth years are also 8. Okay, so notice we can add down this column to find out the total number of students in the class. In other words, the total first, second, third, and fourth years. So 8 plus 8 is 16, plus 10 is 26, plus 7 is going to be 33. So there are 33 total students in the class. Now we can add down these columns to find the total number of A's, B's, and C's. So notice if we add 2 plus 3 plus 1 plus 2, we're going to get 8. If we add down this column, we're going to get 15. And then if we add down this column, we're going to get 10. And this, then just a quick check to make sure everything works. Notice that 8 plus 15 plus 10 is 33. So in other words, we have the same number of total students in the class regardless of how we calculate, so we didn't make any mistakes. Okay, now let's look at the following 4 questions. We'll do one more, but we'll do that after erasing the board. And the setup is, what is the probability that a student chosen at random has these possibilities? So the first is being a second year. So notice how many total second years are there? Well, we already calculated that. That's going to be 10. And then how many total students there are there? There's going to be 33. So the probability is 10 over 33. And we could turn that into a decimal and a percent if we wanted to, but we don't really need to do that. And notice that we can't reduce this at all. Now let's just go ahead and put this into perspective. This is the number of second years divided by the total number of students. That's how we calculated this. Great. Now let's look at the second one. So earned a B. So notice we already calculated 15 students earned a B. So we have 15 B earners over 33. So this is the number of B's divided by the total number of students. So that's the calculation we made to do that. So 15 over 33. Notice this actually simplifies a little bit. We can divide a 3 out of the top and the bottom, and this gives us 5 over 11 if we wanted to. Okay, so now let's look at, is a third year and earned an A? So notice this is only one small square within this, and that would be this part right here. So, sorry, this part right here. So the third year's earning an A, there's only one of them. So our probability is 1 over 33. So this is, notice the number of third years with A's divided by the total number of students. Great, so 1 over 33. Then finally, not a first year, but earned a B. But let's go ahead and put this into a sentence first. So not a first year. So that means this is going to be a second, third, or fourth year earning a B or A. Okay, so those are the properties that we need. Second, third, or fourth year, and they earn a B or an A. So let's go ahead over here and look at this. Okay, so we're not interested in this first row at all. We're only interested in these last 3 rows and actually only the first columns from these last 3 rows. So notice what we'll end up doing is adding all of these numbers together. So notice those numbers represent everybody that is a second, third, or fourth year that's earning a B or an A. So let's see what we get there. We get 3 plus 5 is 8. And then 9, 13, 14, 15, 16, 17. So we have 17 over 33. That's our probability in this case. Okay, I'm going to clean up the board, and then we're going to do one more example using this data set. Okay, so this last one is a conditional probability question. So given that a student earned a B, what's the probability that they are a second year? So often this is written in the following way. So probability that they're a second year given that they're earned a B. That's what this vertical line means. So what that means is we need to do the following. So the number of B earners is going to be in the denominator. And then the top will be number of second years, but not all second years, just second years that earn B's, because we're restricting our universe from all students in the class just to the B earners in the class. So in other words, we're looking only at this second column. So notice there are 5 people that are second years that earn B's. So we have 5 over, and then there are 15 total B's in the class. So it's 5 over 15, which notice that's 1 over 3. So that's the probability in this case. Okay, I'll clean up the board and then we'll do another example. Okay, the second example is going to be looking at the probability of rolling 2 dice and getting certain outcomes. So let's see, the first one is if we roll a die twice or 2 dice once, it's kind of the same thing. What's the probability of getting a 2 on the first roll and an even on the second roll? So these are going to be independent events, which means the probability will be the product of each probability. So let's see, a probability of 2 on the first roll, that's going to be 2 over 6, because we're assuming a 6-sided die, although I didn't really say that here. So that's for the first roll. And then an even on the second roll. Well, notice there are 3 even numbers on a die and 6 total numbers on the die, so that gives us 3 over 6, or in other words 1/2. But now we can simplify this a little bit. Notice 2 times 3 is equal to 6, so that'll cancel this denominator and leave us with 1 over 6 in the end. So there's a 1 over 6 chance of doing this particular event. Okay, now let's look at the sum of 4. Like what's the probability of getting a sum of 4? And here's what we'll need to use here. The total number of rolls, in other words, of different rolls of these 2 dice is equal to 36. And that's because you can roll the first die 6 different ways and the second die 6 different ways, and 6 times 6 is 36. So that's the total number of rolls. Now, the next thing we need to look at is the ways to add up to 4. And notice you can do 1 plus 3, you can do 2 plus 2, and then you can do 3 plus 1. Great. And so notice that 1 plus 3 and 3 plus 1 are different from each other. This one is like rolling a 1 on the first die, but this one over here is like rolling a 1 on the second die. And you can maybe visualize that better if you think about the first die as being blue. So here we're rolling a 1 on the blue die, and then here we're rolling a 3 on the blue die. And here we're rolling a 1 on the, a 3 on the yellow die, and here we're rolling a 1 on the yellow die. But notice if we do this for 2 and 2, there's only one way to do it. So notice that means there are 3 total ways to roll a sum of 4, which means our probability is going to be 3 over 36, which is the same thing as 1 over 12. Okay, great. Now we're going to essentially do the same thing again, but we're going to do it for 10, 11, and 12. So let's start with 10. And notice for 10, we can have, you might think, well, 1 plus 9, but you can't roll a 9 on one die. So you have to start with 4 plus 6, 5 plus 5, or 6 plus 4. So those are the ways of getting a 10. Now let's look at the ways of getting 11. There's 2, 5 plus 6, or 6 plus 5. And you know, we can color these dies if we want. So let's see, the first one could be blue, and the second one could be yellow. And then to roll a 12, there's only one way to do it. It's 6 plus 5. So notice there's 1, 2, 3, 4, 5, 6 ways to roll a 10, 11, or 12, which tells us our probability is 6 over 36, but that can reduce to 1 over 6. Okay, good. I'll clean up the board, and then we're going to do another example. Okay, for our next example, we'll look at this kind of classic setup, which is usually given with colors of balls, but here we've got like different types of cookies. So let's say you've got this bag of cookies. And inside the bag, you've got 5 chocolate chip cookies, 3 peanut butter cookies, and 9 oatmeal cookies. And let's say you are randomly choosing from the bag without looking, and we want to tackle the following 2 questions. If you randomly choose one cookie, which is a chocolate chip, eat it, and then again randomly choose an oatmeal cookie, what's the probability of that happening? So we'll do the same thing that we did before, which is the probability of 2 events happening one after another is the product of their probabilities. So let's find the probability of randomly choosing a chocolate chip cookie. Notice there are 5 chocolate chip cookies in the bag, and there are 5 plus 3, which is 8, plus 9 makes 17 total cookies in the bag. So this first event of choosing a chocolate chip cookie, the probability of that happening is 5 over 17. Now we're going to multiply that by the probability of after this happening choosing an oatmeal. So notice after this happens, we have 1 less chocolate chip cookie in there. So now we only have 4 chocolate chip cookies. So let's put that just as a note for now. So now we only have 4 chocolate chip cookies, which means we have 4 plus 3, which is 7, plus 9, which is 16 total cookies. And then how many of them are oatmeal? 9 of them are oatmeal. So now our probability is 5 times 9 over 16. But notice these are like, there are no common factors between the numerator and the denominator. So the final solution here is going to be 45 over, well, let's see what 17, which is 272. Okay. Now let's look at this next example, which is, let's say, what's the probability that we choose 3 cookies at random, one after another, and we end up eating the whole quantity of peanut butter cookies. In other words, we eat all 3 peanut butter cookies in a row. So the probability of choosing a peanut butter cookie initially is going to be 3 over 17, because there's 3 peanut butter cookies and 17 total cookies. Now, the next probability is going to be 2 over 16, because after this first choice, there are only 2 peanut butter cookies and then 16 total cookies. And then the last cookie, there's going to be 1 over 15, because again, after choosing this, there's going to be 1 peanut butter cookie and then 15 total cookies. So in the end, you have this thing, which is 3 times 2 over the product of all of these. So notice that's going to be 3 can divide into 15 and make this a 5. 2 can divide into this and make it an 8. So really we get 1 over, let's see, that's going to be 40 times 17. Okay, good. But now notice that's the same thing as 1 over 4 times 170. But that's going to be 1 over 680. Okay, so that's the probability of eating all 3 peanut butter cookies in a row. Okay, I'm going to clean up the board, and then we've got one more example to do. For our last example, we're going to look at something that's a spin of a false positive, false negative type setup, but we're going to look at the Google ad algorithm instead. So let's say that we know that 1 in every 200 people is interested in a certain product. In other words, 0.5% of the population is interested in this product, or 0.005. The Google algorithm is 80% accurate at giving the ad to someone who is interested. So that means if you're interested, there's an 80% chance that you will see the ad. And it shows the ad to 5% of people that are not interested. So in other words, if you're not interested in the ad, there's a 5% chance that you will see it. So we can answer a variety of questions based off of this setup, but all of them are greatly made simpler by filling out the following chart. So where this will give us kind of the probability of things happening in all of these types of situations. Okay, so notice that 80% are interested in the product, that 0.5% are interested in the product because that's given to us. And notice that's a total number. So we can go down here and put 0.005 for the total number of people that are interested in the product, which means the people not interested in the product is 0.995. In other words, 99.5%. But notice that adds up to a total of 1. In other words, 100% of the people. Now, the next thing we want to see is how many people see the ad. So we know that 0.5% of people are interested, and 80% of them will see the ad. So let's see that interested and see the ad will be 0.005. So that would be interested, times 0.8, and that would be this property here that's given by this sentence. Okay, so notice that that's actually pretty easy to calculate. That's 0.004, and so that's the number that we can put here. So 0.004 of the total population sees the ad. So that's what we can take by this square right here. And now we can fill this one in very, very easily because these have to sum to this number down here. So that leaves us with 0.001, or in other words, 0.1% of the population are interested in the product but do not see the ad. Okay, so now let's go ahead and fill this in out here. So let's see that not interested and see the ad. So we know that the number of people not interested is 0.995. Again, that was kind of given. And then they see the ad at a rate of 5%. So that's going to be 0.05. So let's see what that gives us. That gives us 0.0498. So let's see, that is seeing the ad and not being interested, and notice that thing goes right here, 0.0498, where I have rounded a little bit. Okay, and now we can fill in this because we know that this number plus this number has to be this 0.995 number, and if we do that, we get 0.9452. Okay, great. But now we can add across, and adding across, we'll get on the top row, we'll get the total number of people that saw the ad, and I should say probability of a person seeing the ad. So this is 0.0538. So that's the proportion of the population that sees the ad, and then down here we get 0.9462. And now we can just check that if we add that last column, we get a 1. Okay, so this is our nice setup. And so let's just dive into what each of these squares means. This means that 94.5% of the population does not see the ad and they're not interested in the product. 0.01% of the population is interested in the product but does not see the ad, and so on and so forth. Okay, great. So I'm going to erase this little calculation and then we'll answer some questions involving this setup. Okay, so now let's do some examples. So for both of these examples, I'm going to set A equal to the people interested in the product, so that event, and B equal to the people that have seen the ad, so that's going to be our other event. So our first goal is to find the probability of A given B. In other words, given that someone has seen the ad, so notice that's going to put us only in this row. So given that someone has seen the ad, what's the probability that they are interested in the product? So notice this is going to give us 0.004 in the numerator because this is interested in the product and having seen the ad, divided by this number right here. So this is 0.0538. So notice we have seen the ad and interested in the product divided by the total number who have seen the ad. And that is because we have this conditional probability. Okay, great. So I'll just say this is approximately equal to 0.0743, which is, again, approximately equal to 7.43%. So that means 7.43% of people that have seen the ad are interested in the product. Okay, I'll erase this part of the board and then we will do another example. Okay, so for our next example, we're going to look at the probability of these complementary events. So if A is people interested in the product, then that makes A prime, or in other words, the complementary event, the people not interested in the product. And then if B is the people that see the ad, then B prime are the people that does not see the ad. Okay, great. And now what we want is the probability of A prime given B prime. In other words, given someone has not seen the ad, what is the probability they are not interested in the product? Okay, so that means we need to look at all people that have not seen the ad. So that will be in this row. So notice that all people that have not seen the ad is given by this probability, or this percent, 0.9462. And now of those people, we want to look at the ones that are not interested in the product. So that's going to be this square right here. So we have 0.9452. And so if we do that calculation, we're going to get 0.9989. Well, approximately equal to that. But again, that's going to be approximately equal to 99.89%. So in other words, 99.89% of people who have not seen the ad would not have been interested in the product at all. Okay, so that's a good place to end this video.